Hi everyone, it's Mrs. Allward again, and today we're going to talk about rhombi and squares. So, starting with a rhombus, the main idea of a rhombus is that all four sides are congruent to each other, which means all four sides are the same length, which means we get to use the distance formula or Pythagorean theorem. So my thought is we have this graph. And if we have the graph, then we can draw those right triangles like we were doing with slope and therefore use Pythagorean theorem. You can definitely use the new distance formula if you like to. There's absolutely nothing wrong with that. There's just a little bit more possibility of errors when dealing with negative signs and minusing and all that stuff. So I tend to use Pythagorean theorem. It's a little bit quicker. So we are going to prove that we have four congruent side lengths. All right. So it's a little bit more work than four slopes, but really not a ton because you're going to see the same pattern over and over and over again. So we're going to graph quadrilateral dock. So D is at 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's D. O is at negative 2, 5. 1, 2, 1, 2, 3, 4, 5. C is at 3, 2. And K is at 8, 5. Now these are 10 by 10 graphs, so hopefully you're able to move around a little bit easier on it. All right, so it should look like it is a rhombus. We just got to prove that. So we're going to draw our little right triangles off of each side. So we can, like our slope, do our rise over run sort of thing. So let's do that. Let's go around in a circle so it's set up for us already. So I'm going to start at K and go around just because that's where my hand is. So I'm going to go up 1, 2, 3, and then 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. It's going to look pretty good to me, right? A lot of threes and fives. So I'm going to do Pythagorean theorem for all four sides. Okay. So I know I'm just going to go around in a circle. So I'm going to do OD first. And I know A squared plus B squared equals C squared, right? So 3 squared plus 5 squared is going to be equal to C squared. So I know I'm going to take the square root. So I'm kind of going to merge my Pythagorean theorem and my distance formula into one. Okay. So watch this. Now you could evaluate that all right now on your calculator, and that's totally cool. I'm going to show a little bit more work just so we can chat about it. So that's going to give me 3 squared is 9, 5 squared is 25, and 9 plus 25 is 34. You don't have to simplify it. As a matter of fact, you can't simplify square root of 34, and don't even bother taking or finding the decimal value. It's too much work. Don't make it harder on yourself than you need to. So OD has a length of radical 34. So then I'm going to find OC. Well, guess what? That's going to be 3 squared plus 5 squared, and I'm going to take the square root of it. Well, why bother showing all that work when I know it's still going to give me radical 34? And I'm going to keep going around. Now I have CK. And again, that's going to be 5 squared plus 3 squared. It really doesn't matter which order you put them in. I'm still going to get radical 34. And then dk. Again, I got 5 squared plus 3 squared. You could do it either order again, and I'm still going to get radical 34. And I've hardly done any work. Okay, so I see that all four sides are the same length, which means it's going to be a rhombus. So I can say doc is a rhombus because all four sides are the same length. And that's all you have to do. On to square. So a square probably has the most work out of all of them because if you remember our little family tree, the parallelogram branches out and you can get the rhombus or you can get the rectangle, and then those two merge into our square. So the square is going to have the properties of our rhombus and our rectangle. So we're going to have to do both formulas. We're going to have to do our distance or Pythagorean theorem and slope because we want to show that all four sides are the same length and we have to show that it has a right angle. Okay, so here we go. So 4 equal sides and opposite reciprocal slopes. But the catch is we really only need to show one opposite reciprocal slope. And since we're going to set it up like we did the last problem, we already have all those little right triangles drawn around it. So it really shouldn't be that big of a deal. Okay. So we have quadrilateral farm. So let's get this graphed. F is at 0, 6. 1, 2, 3, 4, 5, 6. A is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. R is at 2, negative 2. And M is at negative 3, 1. So we draw our square in. And then we're going to draw our little right triangles around the outside. Then we're going to go around our right triangles and find those A's and B's, rise over run, whatever you want to call them. Okay, so I'm going to start here at M, and this is 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. It's looking pretty familiar here, guys. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. Okay. So first we want to prove that it is a rhombus and then that it's a square. Okay. So on top of the four sides. Okay. So find our four sides. So F, right? We're going to do our Pythagorean theorem, 5 squared plus 3 squared. Hey, guess what? That happens to be the same work from the last problem. So that's going to be radical 34. I didn't realize that. Sorry, guys. All right, FA. So 5 squared plus 3 squared equals square root of 34. On the homework, you might have some different numbers. So AR, 5 squared plus 3 squared, square root. We get the square root of 34 again. And lastly, MR, and 5 squared plus 3 squared. Why change it up? We get radical 34. Okay, so we're going to say that farm is a rhombus because all four sides are the same length. And then we're going to find our slopes. Okay, so really you only have to pick two sides, find the slopes. It doesn't matter which ones you pick. So I'm going to go with angle M. So I'm going to find MF and MR, and those will be opposite reciprocals, hopefully. So MF is going up. So it's going to be positive. It has a rise of 5 and a run of 3. So 5 over 3. MR is going down. So it's going to have a negative slope. It's going down 3 and right 5. So it's going to be negative 3/5. So those are opposite reciprocal. So therefore, angle M is a right angle, which would force all the other ones to be right angles as well. So that's what we write now. So now we can say farm is also a square because consecutive, I can't spell this morning, sides have opposite reciprocal slopes. And that's it. So it's really not a ton of work. It's just a little bit long-winded. Okay, so if you have questions, pop on to office hours. Let me know. We can go over stuff together. All right, and I'll talk to you soon. Bye, guys.